if you look at that, the equation on the left, you can tell it's a quadratic equation. You can tell it opens up because the A is positive 1. Do you guys agree? Talk to me. Yes. But other than that, that's all you can tell me. You would have to go through that whole process of getting the negative B over 2A to find the axis of symmetry, plug it in to get the vertex, etc. But if I gave you the equation on the right, you could tell what that thing does really, really quick. You can tell that that shifts 1 unit to the left, horizontal shift to the left, and 4 units down. Do you guys agree? Talk to me. That's a fast way of doing it. What we are going to focus on today is taking this equation and putting it into that form. That's what we're going to do today. And so this, remember, is your general form. And what we are shifting it to is what they call this form, which is called the vertex form. You guys with me so far? Now, the A that you see right here and the A that you see in this equation are exactly the same A, all right? The H and the K are your vertex. That's where the thing starts at. Now, I want to show you a really quick way of graphing, okay, guys? Before I show you this process, I'm going to show you the most fantastic way to graph that you're going to have to really listen carefully. So, let me get my graph out. Where is mine? Okay. Clear this. Okay, is this sideways for you guys? Talk to me.
It's straight up and down. You're good.
Okay, is that better now? Is that good? All right. Let me show you. Now, the basic graph. Don't write this down. Do you guys agree? Now, what the movement was, your vertex was here at 0, 0, right? You went over 1, up 1, over 1, up 1. Do you guys agree? And then you went over 2, up 4. Talk to me. Head wagging really would help me right now. Do you guys agree? All right. Now, this is going to save you boatloads of work. If I put a 2 in front, do you guys agree that's a vertical stretch of 2? So everything's double. Yes or no? So follow my fingers. So it only impacts the Y movement, up and down, correct? The horizontal movement is not impacted whatsoever. We agree on that. So what happens is when you move 1 horizontally from your vertex, instead of moving up 1, you're going to move up twice that amount or up 2. With me? When you move over 2 from the vertex, instead of moving up 4, you are going to double that distance, so you're going to move up 8. Does that make sense? Follow me. Yes? No? Okay. So all you're doing is you're changing how much you're moving vertically. You're not changing the horizontal movement. That's key. So here's a fast way of graphing. You're going to love me in about 5 seconds. I know you can't believe this, but you are going to. Watch. If I gave you the equation, y equals 2 times x minus 1 squared minus 3. Do you guys agree? From your perspective, the vertex has been shifted 1 to the right and down 3. Yes or no? That's your shifting. Do you guys see that? So I'm going to do that. I'm going to move my 1 to the right and down 3. You copy this down. So I did that. I moved my vertex. Remember, everything is symmetric about the vertex. So notice it is a vertical stretch of 2. So that is saying when you move 1 horizontally, instead of moving up 1, you're moving up twice that distance. So you're going to move over 1, but you're going to move up 2. And over 1 and up 2. Are we tracking? So as you're moving over 2 from your vertex, either side, symmetric. Instead of moving up 4, you're going to move up twice that distance, which would be 8. So I move over 2, and I go up 8. 2, 4, 6, 8. and do the same thing by symmetry. 2, 4, 6, 8. I now have my 5 points and I am done. And I have not had to do that negative b over 2a. Does that make sense? Yes or no? Talk to me. All right, let me do one more. And then I'm going to go back and show you how to do that other process. So let's go nasty. So let's go. Y equals negative 1/2 x minus 2 squared plus 3. All right, now first we're going to find the vertex. That shows you that the vertex has been shifted 2 to the right and 3 up. Do we agree? 2 to the right, 3 up. So there's my vertex. You can tell because the graph is negative that it's opening down. Head wagging really helps me. I really need to be sure you understand. Now, if you move 1 over and you know you're moving down, typically you move over and down 1, but since there is a half there, it is a compression. So you're going to go move over 1, but you're only going to go down a half. So you're going to go over 1 down a half. Because half of 1 is half. When you move over 2, you would normally go down 4, but you're going half of 4, so you're only going to move down 2. Boom. And you got your graph. Now, is that a lot faster graphing? Do you guys agree? That's a lot faster. Now, let me go back to this problem and let me show you now how to take an equation in general form and put it in that form. So it is still part of completing the square. So let's take that equation. Y equals x squared plus 2x minus 3. Here's where the difference occurs. You are not finding the x-intercepts. You're not finding the roots, and you're not finding 0. So you do not set it equal to 0. You're not solving it. You're trying to rewrite the equation in different form. So you leave it equal to y. Totally different process. So just like before, you make sure that this number here is 1. It is. Just like before, you move your constant to the other side. So I'm going to go y plus 3 space equals x squared plus 2x space. Process is exactly the same. Are we all together right now so far? You now complete the square. You take half of your 2, which is 1, square it, and you get 1. So you're adding 1 to both sides just like before. Simplify now. So on the left-hand side, you're going to get y plus 4. On the right-hand side, you factor it like you did before. So that would be x plus 1 squared. Yes or no? So remember, we're trying to put it into that form. So we move the 4 to the other side. So you get y equals x plus 1 squared minus 4. Questions? And now that is really nice because you can see you're moving that thing 1 unit to the left, 4 units down, and then it's just a standard graph, over 1, up 1, over 2, up 4. Does that make sense?
Why'd you add the 1?
Where'd I get the 1? This one? Remember, it's a square root, the sine of the middle term, and the square root of the last term. You're factoring it. Does that make sense, Kaden?
No, like in the step before. Like
oh, you complete the square. You take half of the b and square it. That's called completing the square. You're taking half of this. That's what you did last time. You take half of the b and you square it and you add it to both sides. That's how I got the 1.
Okay, thank you.
Okay. Other questions?
So in a question like that, what would they be asking differently than in the other?
They're going to ask you put it in vertex form, and they'll say what is the vertex? You could say the vertex is -1, -4. That's all they're going to do. Okay. Are we good? This just isn't what this gives you, Mallory. Is just another tool in your arsenal of how to graph an equation. in just a different way instead of plugging in numbers. Okay, let me do another one. Let's do a little bit more harder one. So y equals 2x squared minus 4x. We are going to complete the square. So remember, what you have to do is you have to make the coefficient in front of the squared term equal to 1. So the first thing you're going to do is you're going to divide every single term by 2 on both sides of the equation. So it doesn't go away on the left-hand side, notice, it stays there because you're not dividing 0 by 2, you're taking y and dividing it by 2. So you have y over 2 space is equal to x squared minus 2x because there's no constant term to move to the other side. So that's why we have the spaces already. Typically, if there was a c term, I'd move it to the other side. Now, you complete the square. So you will take 1/2 of negative 2 and square it. That's how I'm getting my next term. So that would give you plus 1 on both sides. Have I lost a soul? Am I making sense? Okay, so now we have y over 2 plus 1 equals, you factor this, which will give you x minus 1 squared. Remember, it's square root, sine, square root. It's a fast way of factoring it. Yes or no? Now, move the 1 to the other side. So you get y over 2 is equal to x minus 1 squared minus 1. And now you have to multiply everything by 2. Now here's where the problem's going to happen. When you multiply by 2, you have to do it by every single term. So I'm multiplying this by 2, I'm multiplying this by 2, and this is what you will forget. You're multiplying the 1 by 2. You're multiplying them all by 2, every single term on both sides. So what happens here, it cancels. You get 2 times x minus 1 squared minus 2. Your vertex, since here's your vertex to be moving 1 to the right and down 2. So your vertex would be 1, negative 2. It's going up twice as fast, so it's skinny. You guys with me? So you're going to go over 1, up 2, and over 2, up 8. Yes or no? Does that make sense? Talk to me.
Wait,
You guys
can you
good?
explain that?
Because of the 2 here, remember that affects the y value only. Agreed? So what you're going to do is normally you would go over 1, up 1. That's a standard graph, but you're going to go up 2. You're going to double that movement. When you go over 2, you would typically go up 4, but you're going to double that, so you're going to go up 8.
Okay, I get you.
Okay? Other questions? All right, we got a quiz. Let's get it out. So clear off your desk, get your things set up. No calculators. This is quiz number, I don't know. What quiz is this? This is quiz number 5.